Hi everyone, today we're going to do lesson 3 of unit D, which is involving connecting linear models. In question 1, we're given the equation h equals 4n plus 10, and we're asked to explain or show how we can determine the rate of change and the initial or starting value. We know that the formula for a linear model is dependent variable equals rate of change times independent variable plus initial value. So in this equation, we're already set up with all of that information. We know that the h is the dependent variable, the 4 is the rate of change, the n is our independent variable, and the 10 is our initial value. In question 2, we're also given a linear model. Our equation looks a little bit different though. In this case, our equation is v equals 100 minus 3n. We know that the rate of change is the number that gets multiplied by our independent variable, so this equation has been switched around a little bit. The 100 is our initial value, the v remains as our dependent variable, and the n would be our independent variable. We could reorder this equation so that it follows our typical linear equation model of dependent variable equals rate of change times independent variable plus initial value. If we were to rewrite the equation to be v equals negative 3n plus 100. In this way, we'd be able to line up each of the components of our linear model so that we can identify which is which. The negative 3 would of course be our rate of change, and the 100 would be our initial value. This question asks us to determine the rate of change in the starting value for the relationship that's shown in a table. We know that we can find the rate of change from a table by finding the rise on our dependent side and the run on our independent side. So we can see that our run is going to be 5 and our rise is going to be 10. So to calculate our rate of change, we can do rise over run, or 10 divided by 5, which would be 2. We need units for our rate of change, so we'll look at our dependent units per our independent units. So this rate of change of 2 would be 2 meters per second. We can determine the initial value in our table by looking for the location where 0 is present in our independent column. 0 has the number 20 next to it, which means that the initial value in this case would be a distance of 20 meters. To find the equation for this relationship, we will use our linear equation model of dependent variable equals rate of change times independent variable plus initial value, and we'll substitute the numbers and the information that we know. We'll need a letter for our dependent variable, which we can look to in the second column of our table. So D for distance would work in this case. Then we'll make that equal to our rate of change, which we know to be 2, multiplied by our independent variable, which we'll find in our first column of our table. In this case, it'll be number of seconds, so we can use the letter n for this. And then to that, we're going to add our initial value, which we've already determined to be 20. So our equation would be D equals 2n plus 20. Question number 5 asks us to show how to determine the rate of change and the starting value from a graph. Looking at this graph, we can identify the initial value to be 15. 15 is where the line meets the vertical or the dependent axis. That's our starting location. So we begin with $15. Then we can calculate the rate of change by drawing a rate triangle between any of our two known points. Let's draw it from 15 up to 30, or from 0 visits up to 6 visits. We can then find the rise to be 15 and the run to be 6. This gives us a rate of change of $2.5 per visit. Now we can put this information together to create our linear equation. Our formula will be dependent variable equals rate of change times independent variable plus initial value. Our dependent variable can be found vertically on our graph, so it will be C for cost in this case, and that's going to be equal to our rate of change, which we've calculated to be 2.5. And then we're going to multiply that by our independent variable, which will be the variable that's going along the bottom or horizontally on our graph, number of visits in this case, so we can use n. And then to that, we're going to add our initial value of 15. So our equation for this graph would be C equals 2.5n plus 15. Good. Good luck creating your linear equation models from tables and from graphs.